Hello there, Mr. Sutton here with the IM3 8.3 Part 1 homework solutions on theoretical probability. On this problem, we have Jill playing cards with a friend, drawing a card from a pack of 20 cards numbered 1 to 20. We want the probability of drawing a card that is a square. So by squares, we mean numbers that are the squares of others. So for example, 1 is 1 squared, and 4 is 2 squared. Then we have 3 squared, which is 9, 4 squared, which is 16, and there's no other numbers that are perfect squares that are less than 20. So we want the probability of drawing one of these numbers. Now our total possibilities are 20. There's 20 cards. So the probability of a square is something over 20. Now there's 4 of these, so that's 4 over 20, which we can reduce to 1 over 5. On this one, we have a magician showing a magic trick picking a card from a standard deck. We want the probability that the card is a queen card. So the probability of getting a queen, what's our total number of possibilities? In a standard deck, we have 52 total outcomes. Now the outcomes that we want are just the queens out of there. There are 4 queens in a deck of cards, one of each of the 4 suits. So that's 4 possibilities we want. And then we can reduce 4 over 52 by 4s to be 1 over 13. For this one, we're rolling a 6-sided die. There are other types, believe it or not. We want the probability that the value of the roll will be 1. So our total possibilities are 6, so something over 6. And then there's only one number on there that's a 1, supposedly. So we have a 1 out of 6 probability of rolling a 1. On this problem, we've got a bag with 10 green, 11 red, and 7 blue marbles, and we want the probability of picking each of these colors here. So let's add up all of these just to figure out what our total possibilities are. And then that's going to be the denominator of each of our probability fractions. So we've got 10 plus 11 plus 7. That's, let's see here, 21 plus 7 is 28 total outcomes. So now the probability of red is going to be something over 28. Well, there's 11 reds, so that's 11 over 28. Now for blue, again, 28 is our denominator. This time we have 7 blues over 28. That one can be reduced to 1 over 4. And then for the greens, again, 28 for our denominator, total outcomes. But now this time the desired outcome is number 10 for the 10 green marbles. But we can reduce 10 over 28 to 5 over 14. For this problem, each of the letters in the word Samsung are on separate cards face down on a table. Picking a card at random, we want the probability that its letter will be S or U. So the probability of S or U, we have the number of desired results over possible results. Well, how many possible results are there? Since there's 7 cards, there's 7 possibilities for what we could end up with. So we're going to have something over 7 for this probability. Well, how many desired results do we have? We want S or U. So how many S's are there? We've got an S here, another one here. There's 1 U, so altogether that's 3 different cards that could give us what we want. So then our probability would be 3 out of 7. For this one, we have a bag with 10 black marbles, 20 white marbles, and 5 grays. We pick one without looking, and we want to know the probability that our marble is either white or black. So what are the total possibilities here? We've got 10 blacks, 20 whites, and 5 grays. So 10 plus 20 plus 5, that's going to give us our sample space here, our total possibilities. Now, how many of these are desirable results? We want either white or black marbles. There's 10 black marbles, 20 white marbles, so 10 plus 20 is going to end up giving us our desired results. So then this ends up being 30 over 35, which we can then reduce by 5s to give us a probability of 6 over 7. For this problem, we ask a friend to think of a number from 4 to 12. We want the probability that the number is going to be 8. Well, how many total possibilities are there from 4 to 12? Well, how many possibilities would there be from 1 to 12? We would say there's 12, right? It's always going to be 1 more than the second number minus the first number. So 4 to 12, 12 minus 4 is 8, but we have to add 1 for the 4 in there. So that ends up actually being 9 different numbers. So we have 9 possibilities. And then the desired outcomes, we just want the number 8. That's 1 out of those 9 possibilities. So the probability of getting 8 is 1 out of 9. For this one, we have a bag with 5 blue sticks, 4 reds, and 3 orange sticks. we want a friend to pick one without looking, and we want to know the probability our stick is going to be blue. So what is our total possibilities? Well, 5 plus 4 plus 3, that's 12. So the probability of blue is going to be something over 12. Well, how many good possibilities are there? Well, we want the blue sticks, of which there's 5. So then we would have 5 over 12 as our probability. For this multi-step problem, we have some marbles pictured below here, and they're placed in a bag, and we pick one at random. So it looks like we've got 2 white marbles, 4 gray marbles, and 1 black marble. So we want to know which color is least likely to be drawn from the bag. So that's going to be whatever marble has the fewest representatives here, and that would be the black marbles, of which there's only 1. Then what's the probability of drawing the black marble? Well, overall we have 7 marbles. So probability is going to be something over 7. And since there's only 1 black marble, our desired possibilities here number just 1. So we have a 1 over 7 probability of drawing a black marble. Probability of drawing a gray marble, part C down here, we've got 4 gray marbles. So then we're going to have same sample space. We have 7 total, but now we only want 4 of those. For this next part of the problem, we want the probability of drawing a white marble. Now again, there's 7 total marbles. Only 2 of them are white, so we have a 2 over 7 probability, which we can't really reduce. But now we want, for this next part, the probability of a marble that is not white. So we can do this by simply subtracting the probability of one that is white from 1, basically subtracting it from 100%. So if we do 1 minus 2 over 7, that's really 7 over 7 minus 2 over 7, which gives us a 5 out of 7 chance of not white. And we can easily count there's 1, 2, 3, 4, 5 marbles that are not white. So now down here we want to know what's more likely, drawing a marble that's not black or a marble that's not gray. Well, let's calculate not black first. The probability of a black marble was 1 out of 7. We found that in an earlier part. So probability of not having a black marble is 1 minus 1 over 7, the complement of that. And that ends up being 6 over 7. And now probability of not gray, well, probability of gray itself was 4 over 7. So not gray is going to be 1 minus 4 over 7, which is 3 over 7. Now between these two, we wanted to know which was more likely. 6 over 7 is higher than 3 over 7. Easy to compare since they have the same denominator. Therefore, it is more likely that the marble is not black than it not being gray.